Okay, so now we'll look at the case where instead of a lump sum, we're going to make installments. So if $50 is deposited at the end of each week into an account paying 13% annual interest compounded weekly, how long will it take for the account to grow to $150,000? So in this case, instead of making a lump sum and waiting for it to grow, we're depositing $50 at the end of each week. This is called an annuity. So this number here, 50, that's the value of the payment. The payment is P. So payment is 50. The interest rate, R, the annual interest rate is given here, but we have to write that as a decimal. That would be 0.13. And what we have down here, this number down here is actually the future value, the accumulated value. That's how much we expect to have at the end of however long it takes to grow after doing all these $50 deposits. So that's A. All we have to do is pretty much plug everything in. Oh, the other thing we need to know is that interest is paid weekly. If interest is paid weekly, that means we're going to have a total of 52 interest payments for the entire year. So this means that n is equal to 52. Let's plug it all in. So we have that A, the future value is 150,000. We have that the payments are going to be $50, and then that's going to be 1 plus 0.13 over 52, which is r over n, and that's going to be to the 52 t power minus 1. We're going to divide this by the 0.13 over 52. And what we're trying to solve for is we're trying to identify how long it's going to take. So we're trying to solve for t, the only variable. So what I'm going to do is I'm going to do this. I'm going to divide 50 by the fraction 0.13 over 52. On a calculator, I'd type 50 divided by, and then parentheses 0.13 divided by 52. And this would give me 2,600. So this all amounts to just 2,600. So this is actually 2,000 is what I should, 20,000 is what I should say. 20,000. So when I do this on the calculator, I get 20,000. So this is 150,000 is equal to 20,000 times, and then on the inside here, that's going to be 1.0025. If you divide 0.13 by 52, you get 0.0025. So that's going to be 1.0025 raised to the power of, and this should have been a 52, not a 5, raised to the power of 52t. 52 was the value of n, minus 1. All right, so we can divide both sides by 20,000. Dividing both sides by 20,000, we get 15 over 2 on the left is equal to, and that's going to be 1.0025 to the 52t power minus 1. So we add 1 to both sides. We get 17 over 2 is equal to 1.0025 to the 52t power. Then we take the natural log of both sides. The ln of 17 over 2 is equal to the ln of 1.0025 to the 52t, which allows us to bring down the exponent. So 52t times the natural log of all this, 1.0025, is equal to the natural log of 17 over 2. And then we finally have t by dividing both sides by 52 natural logs of 1.0025. Those cancel, and so do those. And we get t is equal to the natural log of 17 over 2 divided by 52 natural logs of 1.0025. and we can do that calculation.